Let's explore advanced transaction processing with a focus on specialized transaction models. Today we'll be diving into the SAGA pattern. It is an important concept in managing transactions across multiple services. So, what exactly is the SAGA pattern? A SAGA is a sequence of local transactions. Each transaction updates data within a single service. Think of it as a series of steps where each step performs an action in one place. This pattern is particularly useful for managing long-running business processes across multiple services. Rather than trying to manage all services at once, SAGA ensures data consistency without strict ACID properties. This means that while we aim for all transactions to complete successfully, we also prepare for the possibility of failures and how to handle them gracefully. Why do we need the SAGA pattern? Traditional methods like two-phase commit can become complex and unreliable in distributed microservices architectures. SAGA offers a solution through choreography and orchestration patterns, providing resilient transaction management. Choreography and orchestration are two ways to coordinate these transactions, making sure that even if one part fails, the whole system can recover without crashing. There are primarily two types of SAGA implementation: choreography and orchestration. In choreography, services coordinate directly through events. Think of it like a dance where each dancer knows their moves and reacts to others. Orchestration, on the other hand, involves a central coordinator that manages the workflow, similar to a conductor leading an orchestra. Choreography offers decentralized control, while orchestration provides centralized control. Let's take a closer look at Choreography SAGA. In this pattern, services coordinate through events. For example, the order service publishes an event when a new order is created. The payment service listens for this event and processes the payment. If the payment is successful, it publishes another event. If the payment fails, it publishes a different event. Each service reacts to these events independently, creating a decentralized control system. Now let's explore Orchestration SAGA. Here we have a central coordinator that manages the entire process. For instance, an order SAGA orchestrator class might execute the SAGA by creating an order, processing payment, reserving inventory, and shipping the order. If any step fails, the orchestrator compensates by canceling the shipment and releasing the inventory. This centralized approach provides a clear and controlled way to manage complex transactions. The SAGA pattern offers several benefits, including scalability, because there is no need for distributed locks. It also ensures resilience, as it can handle service failures gracefully. Plus, it provides performance benefits with non-blocking operations. However, there are also challenges to consider. Implementing SAGA requires complex compensation logic, making debugging more difficult due to distributed state management. Additionally, SAGA follows an eventual consistency model, which might not be suitable for all applications. Finally, let's look at some common use cases for the SAGA pattern. It's widely used in e-commerce orders to coordinate payment, inventory, and shipping. Financial transfers benefit from its multi-step money transfer capabilities with rollback options. Travel bookings use SAGA to manage flight, hotel, and car rental reservations. Even manufacturing industries utilize it for supply chain and production workflows. These examples demonstrate the versatility and broad applicability of the SAGA pattern. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.